Hello and welcome, my name is Pavel Křupala from blendrefreak.com and today we are going to have a look on PyQt Node Editor architecture. In case you are wondering what the heck is PyQt Node Editor, it's this stuff. I published a whole bunch of tutorials on my website and the YouTube channel, which are completely free, and the tutorials are designed for you to be able to follow along and write your own version of your Node Editor. Now I'm looking for people who would like to jump in, help out with the development of the library to make the most awesome Node Editor library ever. The library is licensed as MIT, so you are free to use it in your own application as you want. In case you are wondering how to get to the code, you can just jump in and download the repository from GitLab, which is located here, or you can just pip install Node Editor and you will get the code as well. All of the links are going to be in the description of the video, as well as any other useful information. So on the left side you can see how the repository looks like. You will get the documentation, also the examples, the Node Editor itself, which is a module, and some simple tests. All of the examples can be run with their main scripts, and all of the source code is located in the Node Editor. So in the code we are using from node editor.something import whatever we need from it. And now let's have a look on the source code of the Node Editor itself. This is how the source code looks like. And when we run the first example test, we can see something like this. So just straight from the beginning, we can ignore the QSS subdirectory and the __ init, and also the utils file on the bottom. When we create an application with PyQt5, we are going to create a Q application and then we are instantiating a Q main window. So let's talk about the first two most important things, and that's Node Editor window, which derives from the Q main window, and also the widget inside, which is Node Editor widget. First thing you see is the Node Editor window. This is the outline. And inside there is a central widget, Node Editor widget. This one derives from the simple Q widget, and inside of this widget there is Q graphics view, which is displaying the Q graphics scene. But more about them a little bit later. Let's just discuss the Node Editor itself, and this is what we are going to talk about. In the case of example test, you will see something like this. When we go to the calculator example, we will see something similar, but a little bit different. However, the architecture is still being the same. I'm going to describe the code on the first example. As I just briefly mentioned, the things you are actually seeing on the right side are being painted with the PyQt5, and therefore what you are looking at is actually a Q graphics view containing Q graphics scene, which contains a bunch of Q graphic items. Everything which is dependent on Qt is stored in respective classes, and all of the files are going to have the node _graphics _ something prefix in the file name. Let's just skip the talking about the graphic stuff and let's talk about it a little bit later. So for now, let's have a look on these files. Now it's starting to make a little bit more sense, since obviously node _edge is gonna describe edge, and node edge _ dragging is probably going to be something with the edges, and the same goes with the node scene, and the socket. The node serializable is an interface containing two methods, serialize and deserialize, and all of the objects which we are using, like the scene, node, socket or the edge, are deriving from the node serializable. If I highlight the files a little bit better, we get just basic elements from which is the scene composed. The most important is obviously the scene, which contains a list of nodes and list of edges. Each node can contain multiple sockets, and each edge can connect two sockets, or it can be even floating somewhere in the scene. This behavior is being used, for example, in the node edge dragging. Every of these elements has its own graphical representation in the corresponding node _graphics _ file. Node, scene, socket and edge, all of them are trying to be independent of the graphics Qt stuff as much as possible. Therefore, all of these classes do represent the business logic of these elements, and they are not trying to do anything with the rendering at all. Instead of that, each of these elements, like for example the node, contains graphic node instance in the variable grNode, the same way as the scene does have grScene, the edge got grEdge, and the socket got grSocket. All of them are references to their respective node graphics classes. So now let's go through all of the elements one by one. Let's start with the most important component in the node editor, and that one is the scene. So if you start looking for scene implementation, you will find node scene file, which contains the scene class. Also, there is scene clipboard and scene history. To not being overwhelmed in one single file, the functionality for clipboard and for history are in those respective files, and the scene class does have variables called clipboard and history, which contain the reference for the instance of these classes. Of course, the node scene does implement the node serializable, so therefore you will find the serialize and deserialize methods. The history and the clipboard do serialization a little bit differently, but they do heavily rely on the implementation in the node scene. Scene class handles nodes, edges, and events as described in the documentation. And this is how the documentation looks like. The events you can use are has been modified, item selected, items deselected, drag enter and drop. The scene class does contain nodes, which is a list of nodes in the scene, and edges, which is the list of edges in the scene. Also, as I mentioned, history and the clipboard do have the implementation or the instance of the scene history class and scene clipboard class. And mainly in the node scene you will find the functions for saving and loading from a file. If loading fails from a file, there will be an invalid file exception being thrown. The scene history also got some events, as you can see here in the documentation, but mainly they do implement the undo and redo functionality. On the other hand, the clipboard does implement serialize selected and deserialize from clipboard, which basically are the main meat for the copy and paste functionality. And of course, scene class does have grScene, and that's a graphic scene class instance. That one is located in the node graphic scene, and in the case of the node editor, the graphic scene handles the grid which you are seeing in the background. This is this one. The major element you can find in the node editor is obviously a node, and the node is being implemented in the file node_node. It also derives from the node serializable, and therefore you will find serialize and deserialize methods at the end of the file. Of course, it has its own graphics representation, and that one is being stored in the node graphics node. So in the node class you will find grNode, which is an instance of the node graphics node. The node can have sockets, which you can see here, but we will talk about them a little bit later. The other thing you will see here in the middle is actually a cube widget, and we call that node content widget. It is basically a cube widget which derives also from the node serializable. Therefore, the content does have its own serialize and deserialize methods. The content can be none, or you can provide any content widget you want. The idea is to wrap the whole content to a single cube widget. As you can see in the documentation, when you are creating an instance of a node, you are passing reference to the scene, also the title of the node, and list of inputs and outputs. These are being used to create sockets automatically for you, so the items in the lists are usually socket types. In the node class you can use reference to the scene. Also there is that grNode, which is an instance of the graphics node, and content, which can be none or it can be QDM graphic content. After creation of the node, it will be automatically added to the scene list of nodes, and also to the grScene, the graphical scene, as a graphical item. To be precise, the actual graphics node instance will be added to the graphical scene. Also in the node you will find a bunch of helper functions to help with the evaluation of the nodes, so we can mark the node as a dirty, or we can mark the node as an invalid one, or we can call eval or eval children. As mentioned before, the node contains sockets, and the socket class is being located in the node underscore socket. Of course, also the socket does implement the serializable, therefore you will find serialize and deserialize methods at the end of the class. And also the socket got its own graphical representation, which is located in the node graphic socket. In the documentation you can see that there are a bunch of position constants implemented, so by default you can use top, center or bottom on the left or right side of the node. And when creating a socket, we are providing reference to the node, index of the socket, position, as I just mentioned from the constants, a socket's type, and additional information if this socket allows multiple edges to be connected in. Also count on this node side, which is a number of total sockets on this side. Basically we are saying with the index and the count which socket it is, respectively which index from the count on this node side, and also information if this socket is input socket or output socket. Inside of the socket class you can use the reference to the node. Also it contains list of edges which are connected to this socket, the gr socket which is the reference to the graphical representation, and also the information from the constructor as I just mentioned. In our case, the socket type does represent basically the color of the socket, and how it's actually being drawn is decided by the node graphic socket. So if you want to see triangles or squares or whatever sockets you want, you should be overriding the node graphic socket and providing that one to the socket class. The next thing to discuss are the edges. The edge class is implemented in the node underscore edge file. There are also other parts of the edge functionality, like the edge dragging for example, or the edge validators, which are stored in those respective files. The edge dragging contains the code which runs once you are creating a new edge by clicking on the socket, for example here, and when you start dragging with the mouse, you will see a dashed line which you can connect to any other socket. Also, when you are trying to create, for example, edge connecting one output to another output, this is most of the cases not desirable behavior, and therefore there are node edge validators. These are basically functions which return true or false if new created edge would be okay or not. If there will be any other functionality added to the edges, it would probably go to something like node underscore edge underscore name of the feature. Of course, even the edge, as any other element, does derive from the node serializable, and therefore you will find serialize and deserialize methods at the end of the edge class. The graphical representation of the edge is stored in the node underscore graphics edge, and there is also possibility to have multiple different edges. I call that edge type, and by default there is implemented this Bezier edge, which you can see here, and also the direct one, which connects two sockets with a straight line. The functionality, how the edges are being drawn, is located here in the file node graphics edge path. This file contains classes for different edge types, and each class got only one single method which calculates the path. In the documentation for the edge class you can see those two constants for the edge type direct and Bezier, and also mention how to use the edge validators. Basically, only thing you need to do to use the edge validators is just somewhere where your application starts, you just need to register the edge validator functions. When you are instantiating edge class, you are providing the scene, which is being stored as the reference here, and also the starting socket and the end socket. Either of these can be none, and in that case you need to access the graphical edge itself and provide the position of the source or the position of the destination. If we have a look on the graphic edge, you can see here are the two attributes, position source and position destination, which determine from where to where the edge is gonna be drawn. The actual calculation of the path is stored here in the Node Graphics Edge Path module, and each of these classes do have only one method called calculatePath or calcPath, which returns the QPaint path needed for graphical representation in the scene. In the Node Graphic Edge, at the end you will find the paint method. This is this one, which actually triggers the painting of the graphics edge. You can of course use bunch of other methods from the graphic edge, like for example the set the destination or set the source, or even change color to be able to set a different color of the edge. For choosing the correct edge path class, there is this method called determine edge path class, and you can extend your functionality on this one. The edge path class used depends on the edge class and of its parameter called edge type, which is being stored in the edge class instance. One of the most important files I haven't talked about is Node Graphic View. So let's go a little bit back and have a look at the whole application. To be able to see the Node editor, we are mainly using these three files. The first one is the Node editor window. Once we create that, there is something called central widget, which can be set to anything you want. In our case, we are instantiating the Node editor widget. However, by itself it doesn't contain anything unless we connect the Node Graphic View inside. Now, inside this Node Graphic View, which derives from the Qt Graphic View, we can display any scene we want. Our scene is actually containing a graphical scene, which is now being displayed. This is how it looks in the example test. In the other example of the example calculator, we can see something similar. However, this time on the right side we do have something called docking area, and as a central widget we are using the MDI area. This actually allows us to create multiple MDI child windows in which we are instantiating the Node editor widgets. So in this case we are seeing on the right side the docking area, and the center widget contains the MDI area. And this is our MDI child containing Node editor widget. But mainly the Node editor widget creates the Node Graphic View. In our case, the Node Graphic View is the main controlling point of the whole editor. By looking at the Node Graphic View, we can see functions implemented in this class. And as you would guess, there are a bunch of events, and mostly they are handling the user interface. Like when you drag a file inside of that area, or if you mouse press or release button. These are the main variables used in the Node Graphic View, and the most important one is this one, the mode. The mode contains the actual state of the Node Graphic View. Node Graphic View is for us working as a state machine, and according to which button or keys we press, we are changing the mode. For example, if we click somewhere on a socket and we start to create a new edge with dragging edge, the mode is changing to mode dragging, and so on. Another example of such a use of the mode is when we are holding the control key and we start dragging on the scene, then we are creating this dashed line. It's a graphic edge which allows us to destroy any connections we got between the sockets. So in this case, when we hold down the control key and start dragging, we change the mode, and once we release that, we are returning the graphic view's mode again to no operation. So I hope this overview was helpful for you, to help you orient in the code a little bit. More information you can find on my website or in the documentation. If you got any questions, feel free to join us on Discord, and there will be definitely somebody who can help you. All of the links are going to be in the description. If you like this video, you can give it a like or leave a comment, or you can subscribe to my YouTube channel. Also, if you want, you can support me on my Patreon page. For now, I thank you for watching and see you next time.